An exponential function has a base that has to be a positive number, that's what this means, and it can't be the number 1. Because if I raise 1 to any power, it's just 1, so that's not a very exciting function. It's just a horizontal line. So in order for this to be an exponential function, it has to be in this form. Just as a review, we can take a number and raise it to a power. And that just means take the number times itself 3 times. But if I take the number to a negative power, that doesn't mean that you're taking negative 2 to the 3 power. What that means is you're taking 2 to the 3rd, and then the negative means reciprocal. So we're going to take 1 over 2 times 2 times 2. So 2 to the negative 4 is 1 over. That takes care of the negative, and then 2 to the 4th is 16. Any number to the 0 power is the number 1. So if I raise a base to the 0, it's 1. I have to be careful, though, if I put a negative in front of the base, because now the base is still 2 to the 0 power is 1, but with the negative in front, that makes it negative 1. That's the difference between seeing something like this, where my answer is 25, versus something like this, where I have a negative and then 5 squared. Only the number 5 is being squared with a negative out front. My answer is negative 25. The other thing about exponents is they don't have to be integers, they can be fractions. So for example, if I have 4 to the 1/2 power, that's the same as the square root of 4 to the 1 power. And 4 to the 1 is 4, so the square root of 4 is 2. Or 8 to the 2/3 power. The number on the bottom is the root, and the number on top is the power. Now you have a choice. You can either do the root first and then the power, or do the power first and then the root. Oftentimes it's easier to do the root first and then raise it to the power. If you decide not to do that, and you take 8 squared, now I have to think of a number times itself 3 times, that gets me 64, and that's still the number 4. With exponential functions, they all have the same basic shape. So if I graph this, I can take a look at the picture of it. So plug in a few negative numbers, a few positive numbers, and then take a look at the shape. So let's start with 2 to the 3rd is 8. So 2 to the negative 3 would be 1 over 8. 2 squared is 4, so 2 to the negative 2 is 1 over. That takes care of the negative. 2 squared is 4. 2 to the 1 is 2. 2 to the negative 1. And then 2 to the 0 is 1. So if you plot this, you're going to see at negative 3, it's a tiny little fraction, but it's above the x-axis. At negative 2, it comes up a little bit. Negative 1, it's a half. Negative 1, it's positive 1/2. And then at 0, it's at 1. That's the y-intercept. At 1, it goes up to 2. And at 2, it starts shooting up a little faster. And at 3, it's all the way up to 8. So this is going to come in looking a bit like a hockey stick. And this hockey stick has a horizontal asymptote sitting right here at y equals 0. Okay, we can also talk about its domain and the range. If I take a look at the function itself, I can tell that there's no square root in this function, and there's no denominators, so the domain is going to be all real numbers. And the range I need to look at the picture. The lowest y value gets close to 0. The highest y value goes up to infinity. So I use a parenthesis on the 0 up to infinity. And that's the graph of y equals 2x, 2 to the x power.